Welcome to our team project, Early Risers, aka the Awesome Team, hosted by Heather, Cody, and Rachel. First, we want to talk about the 7 steps of designing and developing a function. Step 1, clearly define the problem. So with that, we need to answer 4 questions to help us define that problem. One is, what exactly must this function do? So, for example, we want our function to purchase land. Next question, what are the inputs that I need to accomplish this task? So we need amount of wheat stored, we need cost of acres, amount of people to manage wheat, acres owned, and acres to buy. So all this will help us to, these inputs will help us to accomplish the task of purchasing land. The third question we must answer is, what is the output to be returned? The output is total acres owned, because if we're purchasing land, that means we're going to have an increase in the acres owned. Fourth and final question to ask in defining the problem. It is, what validation rules need to be enforced? So for this, we need to make sure that we have enough people to manage acres, because we know from the requirements document that it takes 1 person for every 10 acres of land. So that is a validation rule that needs to be enforced. Next, we need to purchase a valid amount of acres. So it can't be like, oh, I'm buying -1. That doesn't make sense. So we need to validate and enforce that you cannot buy a negative amount. And last, you need enough wheat to purchase acres. So you need to have the goods to buy. And so we need to enforce that you can't just get it for free or for a lesser amount than the required. Step 2 in our 7 steps of designing and developing a function, which is to create the test matrix. You'll see here that we have test case numbers 1 through 7. And we made sure to then put within the 7 at least 4 different outcomes. Because we have 3 different requirements that we need to make sure passes, as we just talked about in the previous slide. We need to have those put, such as making sure there is enough wheat to buy it, that it's a valid amount of acres you want to buy, and that you have enough people to buy it. And so that's where you see the -1, -2, and the -3 for the results. And then we have the other numbers that display for end result, indicating the amount that we should have for the acres owned. So that's where we get the test matrix. So we have an idea of this is what it should end up being like if it all works out. Step 3, outline the solution. So within the step 3 solution, we have 5 steps. The first step is to obtain amount of wheat needed by multiplying acres to buy with price per acre. So we need to know then, okay, if we're buying, say, 30 acres of land and it costs 20 bushels of wheat, we need to multiply it together so we know how much total it's going to cost. Next, step 2, find out amount of people needed to manage the land if purchased. Because once again, we know that for every 10 acres of land, we need to have 1 person manage it. Step 3, make sure that desired amount to purchase is valid. So once again, we need to enforce that and make sure that it's going to be controlled with, in this case, like if statements, so that it's valid for the amount buying. Step 4, find out amount of wheat left from purchase. So we need to find out if we bought 30 acres of land and it costs X amount of wheat, it needs to be taken out from the amount of wheat I have stored away, because I bought it, so I don't own it anymore. And so I need to know how much I have left. Then step 5, update amount of acres owned with the amount purchased. So we now bought it, we own it, so now the amount that we own should increase to the amount that we increased with the amount purchased. So that is the end of step 3, outline the solution within the 7 steps of designing and developing a function.
Step 4, we need to test the algorithm. Writing this code in order will help you prevent coding mistakes. Test the algorithm by identifying the variables used and create a table representing the memory locations for each variable. Next, walk through and execute the cases and the expected value in the matrix. If the values match the cases, it passes. If not, you need to fix the code and redo it. So in our example, we need to make sure that there's memory space for each of our variables. Step 5, we need to translate the algorithm into code. By this, we go into our NetBeans and we change the mock code into actual coding using our UML diagram as our base for our code, and then we translate the statements into Java code until we have translated the entire algorithm. As you see, we have our byland test matrix here, or not test matrix, we have our byland view here.
Awesome. So step 6, we're going to run the test cases to verify that the code is working as specified. So I'm just going to give you an example of what that would look like. I'm going to just share my screen really quick just to show you, and it either passes or it fails. There's no other option for it. So when you run, oh, dang, that looks a little weird. All right. So when you run your NetBeans test, you're going to go down to the package that you want to test and hit right-click it, and then you're going to hit test file. And it's going to run through it and be like, okay, you passed all of the tests or you didn't pass the test. If I didn't pass, it would all be red right here. And I would know that I needed to redo it. The next step, or I guess the 7th step, is going to be deploying the changes to the repository. So again, if I pull that up on my computer, it's going to, sorry, just got to get it actually pulled up. All right, so what I'm going to do is if I want to deploy the changes to the repository correctly, I'm going to highlight the project that I'm working on to make sure that I'm not doing the wrong things. And then I'm going to commit, so go to the team, maybe. I'm going to just go through this way because it's a little bit easier for me. Okay, why am I not seeing it?
Up under team. Go up to the top under team. Oh, why are you not seeing it?
Like it's not actually showing up. I don't know why. Normally you would commit the changes and then save any changes that are there and put a note under those changes that you made, and then you're going to pull the information to make sure that you don't have anything conflicting, that you got everything down, and then you're going to push the information. For some reason it's not popping up on here, otherwise I was going to show you. And that is the end of the 7-step process.
So for my personal project, I picked population to show you. Population is the control coding that I made. My class for this Java is population. The function is calculate growth. The purpose of this function is to get a random number to calculate the new population based on a math function using a random number. The variables are population, and W, with W being the final number used to calculate the population growth given us by the utility.random. This calls and uses the random, and we imported at the top of it to make sure it picks a random number. W will be between 1 and 5. This part of the function defines the errors that are out of the ability of the function or shouldn't be possible using selection statements. And the selection statements are defining the errors. They are if they are somehow called, they should make an error. It uses the if ladder to go through possible errors that could come up. The selection statements control the flow of the program. These are conditional expressions that each are evaluated. The program continues to go through until the statements can be executed. The final result is often the default condition that is run. In my program, it is the calculation of the population. My first selection statement checks for population under 0. If the population isn't under 0, it goes to the next statement and then looks for population too high over 300. The next selection statement checks for a return value of the random value equal or less than 0. The final statement checks that the percent will not be over 5%. If any of these statements are true, an error will happen. However, if they're not true, the final condition or the equation will perform its own calculation. This calculates the random number with the population to return the population growth based with that random number. To make my tests run in the control test, I have to get rid of the random because it won't work with the specific test on random. However, go ahead, Rachel, to the next one. You can see that when I don't allow a random number, the tests work without a problem. In these tests, you can see I've set them without the random number, and so it does have random results for the negatives, such as test case 3. My population comes back with a -3, and in test case, because the W came back as a 0, and we are only allowing that to be a 1 through 5. And test case 4 comes back with a -4 error, because W came back with a huge number of over 101, and it can only be 1 through 5. So we can see that my test cases 1 through 7, I'll experiment with different errors or regular results. And we will go ahead and show you, Rachel, can you run the test population?
Totally.
And show that it runs.
I'm going to share my screen, so for a second there it's going to get really weird. Hold on. Alrighty. So I'm going to run the test population for Heather so that we can see that it runs properly and everything. So coming into, if I actually click the right things, there we go. So Heather did the test population for, well, the population test, I guess I should say, not the. So I'm just going to hit the test file. And as you can see, it runs really great. It has these little numbers on the side that say it went through 1 through 7 as well.
And that is population and my portion.
Okay. Now I'm going to cover over byland, as we had talked about earlier in our presentation. I want to cover over the selection statement. So I have if, else if, else if. So once again, as we covered, we need to be able to make sure using these selection statements that nothing invalid is going to pass. And so we have acres to buy. If acres to buy is less than 0, return -1. So say someone tries to input, oh, I want to buy -2 acres of land. Well, that's not a valid number. So it'll catch that and return a -1 for my testing demonstration purpose. Else if it's not below 0 for acres to buy, it would check for something else now, which is if wheat needed is greater than wheat in storage, return -2, because it means we don't have enough wheat to purchase. And so thus it has to throw an error, which would be the -2, and it would stop it from happening. Then the last check that we want to make sure for our condition is if people needed is greater than population, then return -3. And so it would be another error. As we talked about earlier, for every 10 acres of land, we need 1 person. So it's checking for people needed against population. And this comes over to here. How do we know the amount of people needed? It's up here. We have people needed equals acres to buy plus acres owned. And then we divide it by 10 because each person can handle 10 acres. And so that, and we do math.ceil to be able to round it up. For example, if we're buying 15 acres of land, that's going to need 2 people to get it because one person can only do 10. And so even though it's not a 20 amount, we still need 1 more person to be able to do that. So that's why it rounds upward with math.ceil. And explaining for this wheat needed, the way how we figured that out was going up to wheat needed equals acres to buy times price per acre. And so that's how we're able to figure that out. So now let's go ahead and pull open my actual NetBeans here. And I'm going to then show you here my test cases that I have. And we wanted to, just as we talked about earlier in the test matrix, make sure at least 4 different things in our 7 tests. 1, test to make sure that if we have too few people, it will throw an error of -3. Another one is that we want it to be successful, and then it would give us the expected result of how many acres owned. Another result that we want to find is for negative value to buy. So if someone put in a negative amount, it needs to then give the expected result of -1 because it's not allowed. Then last, we need to be able to at least make sure that if we don't have enough wheat to buy it, then it will throw a -2, catching it and saying you can't purchase it. And so if we now run all this first, we'll find out that it all works. So test passed 100% for all 7. So we know it all works now. Let's go ahead then and break it apart just a little bit for one of the examples, since I've already talked a great deal about it. Let's talk about too few people. And we're going to break it down to see how it works exactly. So first, we want to buy 20 acres of land. So now we are going to then see if we have enough for it. So what we're going to first see is if we have enough wheat to buy the acres of land. So wheat needed, acres to buy times price per acre. So let's look at this. Acres to buy, that's 20. Price per acre, 17. So let's pull up a calculator. We have 20, and then we multiply it by the 17. We have 340. So 340 is what wheat needed holds. So wheat needed is containing 340. Next, we need to be able to then find out the people needed. So that requires acres to buy. So once again, 20 plus acres owned, which is also what we have, 20. So we have 20, and then we're going to add it with the other 20. equals 40. So in total, it would then equal to 40 amount of acres owned. So we need to then divide it by 10. That says 4. So that means people needed represents 4 people in order to successfully make this purchase and to manage it. Then we're going to check through here for acres to buy. We check, okay, acres to buy, it is 20. It is above 0, so we pass this if statement. Now, else if wheat needed is greater than wheat in storage. So wheat needed, we have right here. We've already checked, and we know that we had needed 340. And so we then say, okay, 340, is it greater than wheat in storage? Let's look. We have 500 wheat in storage. So it checks. Everything's okay here. We don't catch it. Last, for our final check, we need to make sure we have enough people needed. So people needed, we already calculated to be 4. So now let's find out if people needed 4 is greater than population. We have here population equals 3. So we need 4 people, but we only have 3. So that means it's going to catch, and we're going to return -3 because that tells us that we don't have enough people for the amount we want to buy. And thus, the expected result equals -3. And that is a clear example of how this test case works. And so we know then that we don't have enough people needed because of the -3.
Alrighty, so my section on wheat eaten, I used an if statement in order to basically check if all of the input was valid. I started with if the tithing was greater than 12, and with the tithing, we want if it was between a certain range, we would choose a random number between a certain range as well. So I wanted to check to see what tithing they entered and if it was between a certain range, and if that was the case, then they had to, or then they would get a random amount eaten by rats. So that's where the random value comes in. But I also had like a couple of others, and then I had to check and see if the input was actually valid with this last else if. I was thinking about it earlier, and I honestly think that I could have just used an if or else statement right here, because honestly, if it's not any of these 3, then it's not really a random, or then it's not really a valid input. So it's not really something that they could enter in. Also, I return the wheat storage so that we have it for later when we need to use it. And go to the next slide. All right, I just kind of included a copy of my test matrix. Cody did a really good job of kind of going over what it was and how it worked. So I'm just gonna go over my numbers really quick. I definitely threw in a couple of negative numbers to kind of say this is gonna be an invalid input. But that's really the only invalid input that we have as far as amount of tithing paid. They can pay as much as they want. I wouldn't necessarily say it's smart to pay 45%, because then they're not going to be able to buy wheat and keep their people alive, but they can. So that's just an example of my test matrix that I did. I already actually ran my wheat eaten test at the beginning, just to show you how it worked, but this is kind of going through it one more time, and just going over that test matrix saying okay, if I paid, oh, that looks weird. All right, if my random number is 10 and my wheat storage is 100, and I paid 100 in tithing, I think I wrote that wrong there, I'm not gonna lie, then I'm gonna have an expected result of 90 because of the equation that I did. And as you can see, you saw this earlier, but all my tests passed, so yay! All right, so in the group code, we wanted to go a little bit over what scope and lifespan actually is. So your scope is the function that it's declared in, the function that your variable is declared in. So for instance, in this example, percent, or well, actually really all of these, but percent is the example that I'm going to use, is in this scope. So it starts at the beginning of this function, this public class or calc harvest function, and it ends when the function ends. So you can't really use it again after this function ends at this end of this bracket right here.
Okay. I'm going to talk about passing by value. So passing by value, it's self-explanatory. It's the actual value is passed on. So for example, we have 15, the value 15 being passed on into percent, or 80 into acres owned. And what's important to know is that when we're passing by value, it copies the data, and the copied data that is changed does not affect or reflect the original value. That still remains the same for the original. So each time then you reuse it and you change it, then it's its own copy, and it doesn't affect the original that it was pulled from for the value. So that is passed by value.
Okay, and passed by reference is a way Java passes information. When you pass by reference, a number or memory address is passed on. It is where the value is stored. For example, in harvest time, all the variables are referenced. All the parameters are by reference. Our variables within this parameter are actually stored away in another package, and this means we are passing by reference because we're actually referencing the stored memory and pulling it into our harvest time control. And that is the end of our program, our presentation.
Thank you very much for watching, and we hope you have learned.